Hello. Good afternoon, everyone. My name is Amit Arora. I'm a professor at Columbia University. And I'm here to talk about preserving truth in the age of AI these days. And I'm guessing you must be wondering why an American has come to Sweden to talk about truth, of all people these days. So, but yeah, it's an important topic. There is more relevance of preserving truth these days than in any other given point in time in the history. So let me, explain why I chose this topic for today. If you look at the internet today and think about the internet as a big shredder of data, we have a collection of synthetic data, fake news, fake data, real data, verified data, human-generated data. There's all kind of data that makes up the internet. And the large language models these days predominantly use the internet as a source of data for training the models. So you can understand what happens when they train the models on this kind of a mixture of data. It's very difficult to segregate what's real from what's not real in terms of an output. A bunch of statistics that we collected at the university, really interesting. I thought I'll present those to you. In 2022, about 10% of the data that existed on the net was AI generated. Today, it has exceeded 50%. That is something huge for us to look at and consider. We also realized that about 3/4 of all the new web pages that are created today have synthetic data on them that has been created by AI as well. Another figure to keep in mind in this story is when the large language models are trained on the internet and they scan through all these web pages, they are inadvertently being trained on the synthetic data that some other AI model had created at some point in time. So it becomes kind of a recursive loop. AI models create synthetic data, and at some point in time, some other AI models, or maybe the same AI models, train themselves on the same synthetic data, and create outputs. Now, are those outputs reliable? Anybody's guess. So what's the problem with that, right? Is that a problem, or is it okay to create synthetic data, train models on synthetic data, artificial data, and then rely on those outputs? Ultimately, the goal for us is to make sure that whatever output the models are creating is reliable and it's trustworthy so that we can base our decisions on it, right? That's the end goal for us. In addition to the efficiency and the speed at which we want the models to work at, which humans cannot at the moment. So we do see a problem. In fact, there are 3 problems that we should consider. One is the problem of the dilution of truth, potentially, that could happen in this process. The other is the compounding of errors. And the third is the collapse of the models. Now I'm going to walk you through each one of them briefly, and then we'll look at how these issues are being tackled as we speak in today's world. The dilution of truth is nothing but mixing of the training data with the real training data, which contains expert insights, like medical research, for example, with some synthetic data that is also created on the same topic, or maybe there's some fake data that has been created in the past. And when you mix that and you train a model on that, obviously it's not going to give an accurate response. And now you have created some additional data in the world, right? Which will not get erased because anything that goes on the internet remains there forever in some shape or form. Another model picks up all that created data as well as the original data and trains itself again. So it's a recursive thing that happens. So ultimately, after a few years, the output that you will see would be very different from what the original research called out as facts. That's a concern for us to look at. The other issue is the compounding of errors, the autocorrect trap. A lot of softwares have autocorrect options, and without human intervention, without anybody looking at correcting those errors, the meaning gets lost. The semantics and the syntax issue comes in. You're fixing for the syntax, but you're losing the semantics in the process. So the compounding happens, errors become more pronounced, and that's because models are created to focus on likelihood rather than verification of the data that they are being trained on, right? That's the end goal. This is how the models are mostly, programmed to work. And that results in what we already know as hallucinations in the end, right? And the third is the topic of model collapse. Model collapse happens when you have a self-referential behavior being displayed by the models, when the models are not being continuously trained on a continuous stream of real data over a period of time. Think about digital twins. Boeing or Airbus develops new planes. They're looking for aerodynamic qualities and properties of the wings. They have to kind of expose their training models to real-world conditions at all different points, under different weather conditions, different temperatures, pressure conditions, and constantly adjust their designs. Because if they don't, then at some point in time, the designs would be very different than what the real conditions look like. So what that means is, without training your models continuously on a stream of real verified data, the models will start to decay and drift, and they will not become reliable at some point in time, right? So what's the real world impact of these three problems? Obviously, the knowledge pool that we sit on, that we are exposed to today, will start to collapse. It will become untrustworthy, unreliable. What we teach in universities, the research that we rely on to make decisions, the policy decisions that the governments make based on these recommendations, for example, the infrastructure that's being planned across countries and across cities based on such decisions would not be right, and at some point in time, they might result in catastrophic, situations as well. There is an increased risk, and that risk would lead to some event or events, and those events would lead to the public trust being lost in those models and the efficacy and the trustworthiness of those models, right? So is this something that's happening today? Started to happen when the models were introduced, the large language models were introduced a couple of years ago. There was a lot of hallucination in them. They were not trustworthy, but then obviously there are techniques that companies deploy, and they have been deploying. So we'll talk about what those techniques are briefly. But again, in terms of the timelines to the tipping point, if nothing were to be done, or if nothing was done, hypothetically, given the amount of synthetic data that we have today or next year, which is more than 50% on the web, it gets trained on the models use that. The predictions become shallow, repetitive, and summarized. They stop to kind of mimic the real world conditions, and at one point in time, the models become invalidated, and people stop using the models, hypothetically. So the question is about how are companies preserving the truth? How are large language model companies preserving the truth? There are three basic techniques or methodologies that are being deployed today as we speak: data provenance, dynamic benchmarking, and cryptographic watermarking. When you look at data provenance, it's similar to you know, us consuming organic food. When you look at an apple, which is certified as organic, what that means is you can trace where the apple came from, which orchard did it come from, what were the growing conditions under which the apple was produced, how did the farm treat the apple, what was the supply chain look like, and how did it reach the grocery store, right, in the same condition without getting tampered or replaced. So similar to that, if we can think of applying the same analogy to real data, can we track the real data that is being used to train a model? Can we verify the source of that data? Can we make sure that it was not tampered with while it was being processed? And can we obtain certain level of traceability of that data, right? If you want to look at, if all those conditions are met, then the companies build a greater level of trust in terms of the users who are making critical decisions by using their model outputs. The other is dynamic benchmarking. It's similar to a pilot being trained in terms of how to fly a plane, for example. So in the earlier days, when there were no simulators to train on, you would have paper exams where the pilots would go through the manuals, memorize those manuals, flip a switch if this happens, do this if that happens, and they pass some exams. So it's a one and done kind of a thing. But with simulators, the pilots are exposed to varying weather conditions, varying stress conditions that they have to fly a plane on. And if they make an error in the simulator, those errors are captured, reviewed. The pilots are then trained back on how to not repeat those mistakes. So it's a reinforcement learning kind of an approach, which helps reduce those errors, the noise, and makes the pilots more trustworthy to fly a plane and more credible to fly a plane. Similarly, when you apply that thought to data, and how do you curate the data to be error-free all the time, or most of the times, you can apply a benchmarking approach where the errors are constantly taken out from every iteration of the training cycle. Somebody's looking at the errors, taking them out, and retraining the models based on some kind of a reinforcement learning, which preserves most of the truth and most of the efficacies that you need from the model. So that's another way. And then cryptographic watermarking is, this is a different dimension, I would say, because the focus is not on traceability or accuracy of the AI outputs. This is when, let's say you're looking at this image of a skyline, and you don't know if it's a real image or an AI-generated image, right? Cryptographic watermarking helps embed invisible markers in the data that is used to train the models, and also the data that's being produced, because those markers continue in the output as well. So if you take a magnifying glass, I'm just making it up, and you look at a math signature in that image, you can make out if that image is AI generated or not. So in this case, the use case is different. You're not looking for, as I said, traceability of the source, because there is no source in this. You're looking for whether it's AI generated or not AI generated. And therefore, if you have an accountability point of view, then you can make that. So different things are used for different purposes. Data provenance, of course, is the most expensive way to kind of preserve the truth in your sources of the data. It comes with a high manual labor cost, a lot of interventions. Again, if the use case is that the doctors, financial services, healthcare systems have to rely on AI inputs, they would probably rely on a model that has adopted data provenance techniques in training their models. When you look at dynamic benchmarking, the use cases could be different. This is where it's not as life impacting or threatening as the earlier use case, but in this case, for example, if you're looking at a chatbot which is processing customer refunds on a website, it could be accurate most of the time, but it does make some errors. Maybe the benchmarking technique could help where you're reducing the errors and then making those bots better over a period of time. So it becomes more trustworthy and reliable for efficiency purposes. And cryptographic watermarking is, as I mentioned, another technique where you're trying to look at whether this output is AI generated or human generated. I, as a professor in universities, we predominantly use this one because when we give an assignment or a research paper to be written to the students, these days a lot of students use AI to prepare assignments and do the homework. And we have these tools inbuilt in our evaluation system. You click a button, it tells you whether this paper was written predominantly by AI or by a human being, right? So we tend to then go back to the students and make interventions. But again, this was what I wanted to talk about. I hope you found this useful and worth your time. Thank you so much.